Welcome to this video lecture series on the subject Optical and Microengineering. Today we are going to discuss about directional couplers. So directional coupler is a microwave passive device. It has 4 ports. So it is a microwave passive device. It is used for coupling a fraction of power, particularly used for power measurement or standing wave ratio measurement, impedance measurements. So it has to couple a known fraction of power in the auxiliary line because the main transmission line we cannot disturb the transmission. So we are taking a fraction of power in the auxiliary line and we are taking the power measurement, SWR measurements like that. So here there are 4 ports. Port 1 and port 2 are connected in primary waveguide. Port 3 and port 4 are in secondary waveguide. So here port 1 and port 2 is the main transmission line. So in the input power given to port 1 is going towards port 2. And there is a port 4 which is a coupled port. It means the power is fraction of power is taken and given as the coupled power to the port 4. So what happens to the remaining port, that is port 3? It is an isolated port and it is matched terminated. So there is no power transmission from port 1 to port 3. So this directional couplers can be used to measure the incident and reflected power or standing wave ratio. Here are the properties of directional couplers. So consider there is a matched termination at all its ports. The properties are: a portion of power traveling from port 1 to port 2 is coupled to port 4 but not to port 3. Similarly, in the opposite direction, from port 2 to port 1, the power is coupled to port 3 but it is not given to port 4. So one port is the isolated port in either direction. So these are the some performance parameters of a directional couplers: coupling factor, directivity and isolation. So coupling factor means here we can measure the ratio of the incident power to the forward power. It is measured in decibels. So we are considering the input power and forward power, that is the power given to the coupled port. So it can be written in dB as 10 multiplied by logarithm of base 10 and P1 by P4 or Pi divided by Pf. So this is the coupling factor. And next parameter is directivity. So directivity measures the ratio of forward power to backward power. Here, because the only one port is the coupled port, the other port is isolated port. So it measures the forward power Pf or P4 ratio to backward power. So in decibels it is written as 10 multiplied by log of P4 by P3 or Pf by Pb. Next parameter is the isolation. So isolation is defined as the ratio of incident power to the back power. So it means we are measuring the input power ratio of back power that is measured at the uncoupled port. So next we are going to consider one of the two-hole directional couplers. It consists of two waveguides, that is primary and secondary waveguide. There is a tiny holes in between them for the transfer of signal. The two holes are at a distance of lambda g by 4. So it is guide wavelength. So fraction of wave energy entered into port 1 passes through the holes and radiated into secondary guide, because the holes here act as a slot antennas. So as the property of directional couplers we know it, the power is transferred to port 4, that because the forward waves in the secondary guide are in same phase, so they are added at port 4. But in case of port 3, the waves transferred from port 1 are out of phase by 180 degree. So they are cancelled at port 3. So here it is an isolated port. So we can now get the parameters of directional couplers using the scattering matrix. So here consider a 4-port network. It consists of a 4 ports. So we can write 4 cross 4 matrix. We are going to apply the properties of S parameters. So what are the properties? For a matched termination, that is the ports are matched at all the ports, we can write the diagonal elements are 0. So here it is mentioned from S11 to S22, S33, S44, all the diagonal elements are 0. And we can apply the symmetry property also because it is a reciprocal network. So it means the transpose is equal, or we can write Sij equal to Sji. So by substituting these properties and also the coupled port, that is port 1 and port 3 are there is no coupling. So S13 combination S31 are 0. Similarly S24 and S42 are 0 because there is no power flow from port 2 to port 4. So these two combinations are 0. So we are substituting all the values in the scattering matrix of directional coupler. And next, for a lossless network, we are applying a unity property, that is the multiplication of conjugate matrix with the original S matrix gives the identity matrix. So by solving this matrix relation, we get 3 set of equations, and we are going to solve this using the unitary property. So after applying all the substitutions, we get S matrices in terms of zeros and P and JQ. Here what means P is, it is a transmission factor, and Q means it is the coupling factor. So these are the scattering matrix of a directional coupler. So now we can have small assessment. It is based on power dividers and couplers. So these are the components used for power division or power combining. So which option suits for this statement? These are passive devices or active, linear and non-linear devices. The answer is this. These are passive devices because when the input power is given to one port, it is divided equally at micro frequencies, so power dividers are used. So these are the passive microwave components. They do not store any energy. Okay, next question. Isolation of a directional coupler is the measure of which of the following? Here power delivered to the uncoupled port, power delivered to the coupled port, or power delivered to the second port. None of the mentioned. So we know that isolation is used to measure the ratio of forward power to uncoupled port. So the answer is power delivered to the uncoupled port. So thank you for listening this video lecture.